Hello to my friend, my name is Ali Ibrahimi. Today we have a fantastic project. It's for astronaut guys. I want to modeling a spacer discover. It's a model of the telescope manufacturing and I want to modeling in Inventor. This is the all result of the telescope. You see it have a lot of mechanism rotate about each axis and I want to modeling all parts. First I want to start it from the I want to modeling the camera side holder, change it to select two parts. This is the camera side holder. I open it. Okay, let's go to the modeling part 1. Part 1, side camera holder. Let's go to the first, this cylindrical shape, but I want to use the revolving option. Okay, the outer circle diameter is 22, the inner is 18. The length of the cylindrical is 20. Go to the Inventor, select the sketch, select the base plane, XY. Okay, I want to choose a line, but it should be the center line. Select the center line, make a amount to 20 millimeters. Select the rectangular, but it's the center line. Select all and deactivate it, but the option activate again, select on it. Okay, the outer diameter is 22, the inner is 18, the length is 20. Okay, it remains to make a relation from the first line to origin to fully constrain. Exit the sketch, use a revolve, okay, it's automatically choose a profile, but it should be closed loop and axis. We have a chamfer from the inside and the outside of the circle. It's the 0.5 millimeters in 45 degree. Okay, inner, outer, inner, outer. You can change the material to aluminum 6061. We have a two hole, it's the thread, it's M2.5 millimeters, but it's the middle of the cylindrical. We should run a plane, mid plane. Okay, it's created in the middle of the cylindrical. Select this plane, sketch on it. To see the plane, select the slice graphic. Here we have the two center, two rectangular, but the center is aligned to origin. Okay, don't use a rectangular because it's perpendicular about the vertical axis. Okay, make a line from the middle, but select it for construction. Again, deactivate the construction line option. Okay, the center of the rectangular about the y-axis is 45 millimeter. It's the 90 degree divided 2. It's 45 degree. Okay. Here about the top of the rectangular, about the origin, the length is 12. Make a tangent. You can cut it or make a coincidence. All the edges should be perpendicular each others. Okay. About the length is we have a thread is M2.5. You can use about the length 5 millimeters. Right click, select the line. It's 5 millimeters. Okay, let's check the others. It should be fully constrained. Okay, let's stay perpendicular about this line and this construction line. Okay, it's fully defined, or you can change it to 4 millimeters. Mirror it about the y-axis. Mirror line about it's here. Okay. Extrude it. This purple and other, but it's the it is the symmetric. It's 4 millimeters. Select OK. It's create. Let's hide the work plane. We have some chamfer from the around of it. It's the 0.5. Change the amount to 0.5. Okay, select line all around. About extrude. Okay, use a hole M2.5. Select the tapered hole. It should be true and full depth. Use isometric M2.5. This face. Okay, I should mirror it. Accept. It should be the perpendicular. Okay, exit, but again edit it. It shouldn't be the spot face. It should nothing. Okay. Again redefine. We have a problem here. Okay, it's about the direction. Mirror it. This feature about the XY plane. Okay, let's edit. Let's cut through all the cylindrical. Make a distance 7 is good. I want to make this bottom of the cylindrical base. It's the 14 millimeters distance from the bottom of the cylindrical. Make an offset plane from the middle XY planes. Change it to 0.25. It's the half of the cylindrical diameter and the 14 distance in the drawing. Okay, select this sketch and make it rectangular, but back to the cylindrical, this line and this line to see. All boundary of the cylindrical. I want to make a relation. Okay. Here it's the 12 and 4.83, but it's the 5. It's the 12, 5, 12 lengths, and the 5 it gets. Okay. Again, select another plane, but I want to select the tangent, this cylinder, and the top. Okay, sorry, bottom. Again, make a sketch. I want to double it. It should be I want to half of this diameter. 12 should be 6. The width is 2.5. Make a relation. Okay, I want to project again. Boundary of cylindrical to make a relation. Okay. Here use a draft. Sorry, loft. I want to use a loft. This boundary profile and this boundary profile here. We have another option here. Look, I want to change it. It's make fatter, or also about this, it's make it thinner. Okay, the flange should be upper. Make an offset plane from this about 3 millimeters or also 2 millimeters. 0.5 millimeters, hide it. Okay, use a loft. This sketch already fine to drag it the display to top. This sketch redefined to this work plane. Okay, it's good. Look, it shaped the arc of the cylindrical, but the mistake was about it should be the offset of from the tangent plane. This plane, right click on visible. We have here two hole. The hole is M2. It's the middle of the width. The between of the center axis is 7 millimeters. We have a two hole thread M2. Go to the sketch. Make a relation between this hole and the width is the middle of the width. The between the center is 7. Also we have a 12 here. 12 minus 5. It's 12 minus the 7 is 5. About the each face is 2.5. It's for the constraint. Or change the distance to 4 millimeter and 6 depth of the hole. Okay. We can change the law. It's good. It doesn't tear from this face. Let's check the drawing. We have a 0.5 fillets each bottom of the structure. Okay, here we have the reduced 3 fillets. 3 fillets. Okay, it's finished. Part 1 is done. Let's go to the part 2. It's the bottom clamp to stick this case telescope. Okay, here I want to use this arc and make a 2 millimeter offset to reach 23 radius. First we have the arc is 21. Create a sketch. Make an arc. Okay, it should be the vertical end and the first point. The arc diameter is 21 millimeters. Center of the arc should be a vertical relation by origin. Okay, it just you can just create the hub of the arc and make a mirror about this construction line. Deactivate the construction option. Okay, make it offset 2 mm this arc. Again. Edit these lines to allow 2 mm. Reach these points. I want to trim it. Okay. We have that this distance is 6 mm. It's the double of the tree. Okay, always 2 mm. Make a relation these offsets. Okay, the center of the arc is moving. Make a relation. Again, coincident to origin. I want to select the rectangular to create this pocket cutting. It has the length 2291 minus 28.91. It's the 6 from the length, from the width, and have a length here. Okay, the width is 4 mm. The length is 6. But here have a tangent from the bottom. A circle for the bottom arc. Make a relation. I want to trim it. Okay, it's the 4 mm, but also here it should point it apart. Okay, make mirror all about the construction line. Done. Okay, repeat again. Okay, make a trim. Delete comments and trim it. Delete Y. Okay, make offset. Make offset from the rectangular to 2 millimeters. Make the offset to 2 millimeters. Make offset 2 millimeters into outer boundary and trim it. Okay. Here make a mirror these arc parts about the construction line. Again, doesn't work. Okay, let's trim the extra line. Okay, let's extend it. Now at first I want to delete it. Again, extend. It's about 6 millimeters. Let's make error. Okay. Delete it and extend. Okay. Let's trim the extra line. Remain one. Again extend. Okay, here make some relation to fully constrain. Make vertical relation by the origin. Okay, it's fully constrained. Exit. The thickness is 8 millimeter. It's a symmetric 8 millimeter. Okay, we have some fillet here, but I want to make it end of the work. Here we have a hole and we have some okay, here we have a circle shape and make a hole M 1.4 millimeters, but the diameter of the circle is 2 millimeter. Here make a sketch. The circle 2 millimeters. Make tangents and use arc. It should be tangent between the circle and its face. Okay, make amend to 1 millimeters. Make it equal this arc and this arc. Coincidence. Here make a center of the circle and here relation. Again from the bottom. And make a relation. Okay, exits. Make amends. Okay. We have a hole here. It has a thread. Make a concentric from the circle is 1.04. It's fully dips and through it. Okay. We have some fillet here. The fillet about the round is 0.5. Okay, make mirror this feature. Hole and fillet about the XY point. Repeat again. Here just the hole. Okay, make a XY plane. Accept. Delete this feature again. It's make a error. Make a hole. Sorry, I didn't select the extrusion. Okay, it's done. It remains just one of the line to be fillets. Okay. We have a hole here. It's M5. The location is the middle of the lens and the width. Isometric, change it to M5. It shouldn't be true. Make a distance. Go to the sketch and make a relation about the width way. We have a fillet 2 from the top. Okay, about this sitting, we have a hole here. It's M2 from the inner lens is 3 mm, but the width is the middle. M2. Go to the sketch, make a relation about the width in the middle and have a lens 3 mm. Here is a 3 mm. Okay. Next, it creates box. Let me check again. We have a problem. I will think in a base. Here. I change it this line to 6 mm. Okay, let's check. Okay, it's okay. I have a mistake from the one of the lens. Here we have a fillet. You can use a 2 mm. Also, you can make a fillet here, but it doesn't matter because it's just for the sake. Okay, our part is here. It's finished. Also, we have a fillet here. It's 8 mm. Okay. Make a fillet. I meant 8 mm. Sorry, it's okay, it's for the extrude. Part 4 upper clamp. It's like the bottom clamp. It doesn't difference in drawing, but we have a cutting slot here. Okay, select the plane, arc. The diameter of arc is 21 and we have a two offsets. Go to the sketch dimension. It's 21 millimeters. Make a relation between the center of arc and origin. Make a coincidence. Again here and the end of the point of arc. Okay. You can sketch it on a half. After that mirror it all, but it doesn't difference. I did it before by mirroring. Okay, let's go to the drawing here. From the arc and here it's 5.85, but it means it's 6 millimeters, make it equal. Okay, go to the offset, select it 2 millimeters, extend the offset on the before sketch. We have a arc here, or it's a fillet. The fillet is radius 1. Okay, exit. The thickness is here. The thickness is 8 millimeters. Select symmetric 8 millimeters. Okay, we have a fillet. Here it's 1. Okay, let me check again. It's radius 1, and we have here it's radius 0.5. It's radius 1. Click to add. Don't change the order here and here. It's radius 0. Okay, let me check from the top view. We have fillet here. It's again 0.5. It means it is this face and this face. Okay. I want to make a sketch here to cut the slot. Okay, make a relation. It should be parallel. Go to the drawing. It's the diameter is 1.5 and the length is 3.5. And the length from the center is 3.5. Okay, make a relation to should be in a symmetric of our profile. Let me check again. Okay, it should be tangents. Okay, it's fully constrained. Let me cut. Yeah, but it should be cut to all. Both. We have a problem here. Sorry, it should be 6 from the top. Okay. Make mirror this feature. Here it's about the XY plane. Go to the fillet. The first we should calculate it. It's 0.5 millimeters here. Choose a fillet. Okay, and this edge. We have a thread from the top here. I should create a plane, but it should be tangent from the top. I want to choose this arc and should be parallel from the XZ plane. Sketch on this plane. Just make a circle. The diameter is 6 and we have a thread M4. It's 6 exit. I want to calculate from the height. Also you can calculate from the center. Here. Top from the center is 25. It's 25. Let me calculate it. Okay. Here to here, but it's 2 millimeter. Make a hole on it. It should be full thread and through all isometric M4. Select on this surface. If you drag it on a circle, it should be concentric relation. Okay. Hide the plane. We have a fillet on it. The fillet is 0.5. Also here on the bottom. Okay. I think it's finished. Yes, this part is finished. Let's go to the part 5. Part 5, it's a fixture. It has a 3 leg and on the top of that we have a 1 leg extra. The angle between each leg it's 120 degree and the width of the leg is 8 millimeters. About the length, we have the top of the leg length to origin is the 43 degree. The thickness is 10 millimeter. Okay, make a sketch. Select a circle. The diameter of the circle is here 56 millimeter is the diameter. It's 56. We have a rectangular here from the top of the legs and the center we have a 46. Okay, let me check again. Here is 43. Sorry, it's 43. Let's make a relation from the midpoint of the lens and the center. It should be vertical. About the thickness, we have the 6 millimeters. Again, check it. It's 8 millimeter. Edit. Okay, trim the extra line here. It's extra. Okay. It should needs another relation. Okay, it's fully constrained. Exit. Make amends 10 millimeters. Okay. Delete the extra sketch, we don't need it. We have a fillet here is 2 millimeters radius. About the piece edge. Okay. Select the circle pattern. It's 3. The degree is 360 degrees divided 3 legs. Okay, sketch another on this face. We have another cylindrical that the length is 29 from the bottom face. Make a circle 46 diameter. Here I want to check it to top. Exit. Make extrude. Okay. Okay, create a plane and offset from this face about the 4 millimeters. It's from the here 14 minus 10 is 4 millimeter from this face and this face. Okay, make a sketch on the new plane. Make a circle 36. Exit. Select the loft, this profile and this profile. Right. Hide the work plane invisible here. Select the fillet, make the amend 0.5 millimeters. This face. here. It deflects 0.5. Okay, let's go to the volume, the cylindrical shape, 35. Make a circle, diameter is 50, and the length is 8 millimeter. Okay, let's check it in drawing. The diameter was here, it's 50. You can make the sign diameter back, and length is here. From this X roll leg here, it's the height, it's 8 millimeters. Okay, we have another sketch on it to create X roll leg. You can select the right view again. Okay, it's here. The width is 10 millimeters, and about the top of the legs, and the origin is 30 millimeters. Oh, also it's here. I check it in top here, 30 and 10 millimeters, and the height is here. It's 7 millimeters. Okay, make a circle. The circle diameter, it's here, it's 50. Okay, make a rectangular here from the top of the leg, and the center is 30, and the width is 10 millimeters. Let's check it from the about the y axis. It's 19.30. It's 19.63. Also, you can take it from here. It's 10. Let me check again. Okay, from the top, it's 20 millimeters. Okay, trim the extra line here. Finish the sketch. Was extrude, it's the 7. Okay. It's also shape. The shape as a result. Here we have a hole here. It's M4. Go to the sketch. Make a perpendicular view from the top of the leg. It's 7, and about the width, it's the middle of the width here. Okay, exit. It should be through all and full thread. Okay, select circular pattern. Select the feature hole, and the rotation axis, it should be 3. Okay, it's created to all. Also, it's here. Okay. Okay, select the view, go to the here, the hidden line. Okay. Also make here two properties of the hole is M4, and again here it's the 4.5 millimeters. Okay, I think I make a mistake. Let's edit the hole. It's just hole 4.5. Okay, and we have here hole on this face. It's M4. The depth is 7. Oh, also you can select unselect the full depth. It's the 7. And part 6, it's the eye components seeing in the camera. It's the end of the components. We have a rectangular here. Let's go to the drawing. From the top lens it's 4 millimeter. From the bottom it's 19. The degree is 30 millimeter. Make a rectangular, but the top edge is 3. It's 4 millimeters. From the bottom it's 19. Make relation between the midpoint of the line from the bottom and top. Again, coincidence, the midpoint and the origin. The angle between the lines is 30 millimeters. Okay, its thickness is 26, but it's the midpoint is symmetric. Okay, we have a fillet here. The fillet is 8 millimeter from this edge. Okay. We have a rectangular pocket here, but the all edge, all the corner has a 1.5 millimeter fillet. Select an sketch on this face. Make a rectangular. Also, you can use the polygon, but select again. For example, it's 6. Change it to 3. You can select a rectangular shape. It's faster. Okay. Make a relation between the midpoints from the top and the origin. Okay, again make a horizontal lens from the bottom, and the origin is 13. Trace, make a coincidence to stick together. Okay, it should be 60 degree. We have a fillet 1.5 millimeter each corner. Also, I want to make amend. Okay, it's create, it's fully constrained, exits. We should cut it. The depth of the cut is 1 millimeter. Cut it about 1 millimeter depth. Like make a mirror this feature. It creates. Okay, make a sketch on it. We have a square cut. A square cut is 12. All corner is 0.5 millimeters. Okay, make a relation. This length is equal this length. It should be a square shape. It's 12. Make a relation from the midpoint of this length and this line. Change it again. The relation should be horizontal. Okay, make a fillet. It should be 0.5. Also, you can make an amount fillet in 3D model. Exits. Cut extrudes all. Alright. Let's check it again in drawing to make sure the part is finished. Okay, this part is done. Let's go to the part 7. Part 7, it's from the camera to magnify the lens. Okay, I want to use the revolving order, make a capture or save image from this drawing and do it on yourself. Okay, go to the sketch, select the YZ plane, define a center line, but it's for construction. Transfer to center line. Okay, deactivate both. Select a line and select this line as the drawing picture. Okay, make a relation. Vertical, it should be parallel this length and this length. Also here from the midpoint and the origin. The length here is 2 millimeters. It should be top and 12 millimeters. This length is 4 millimeters. Again, it's 4 millimeters. Here is 7 millimeters. It's not too sharp, it should be 3. It's 0.5 millimeters from the top, and this point it's 2 millimeters. We have a fillet here, it's 4. From the distance and the sensor, it's 25 diameter. Here it's 21 diameter. This image is 1 millimeters. Also here is 1 millimeters. 1. From the first line is 19. From this line and the origin is 23. Here is 15 millimeters. It's 20 millimeters. Also it's 18 millimeters. It's 13 millimeters. From the top, this line is 22 millimeters. Here it's 18. It's 16. It's 14.5. And here we have a 16.5. Okay, it's all is for the design, but it should be a little tidy. Okay, exit. Select the revolve. It's automatically do it for you. Okay. It's shaped. Change the material to 6061 aluminum. Okay. Here's the chamfer. make ambient to 0.5. Again, we have this line. Okay. Create here hole. You can select the YZ. Okay. You can set the X set point. Sketch it. Make a point here. It should be the middle of this line. Okay, for the constraint, go to the hole. We have a hole here. It's isometric, it's M2. Also, it's full depth and true. Like, we can change the direction. Make it okay. Okay, let's check it. In drawing, we have M2. It's from the first line. Also, it's I dimension it from the end. The end to center of the hole is 60 millimeter. Create the plane on this face, but it should be tangent to surface and parallel to plane. Okay, select this face to tangent and make exit to parallel. It doesn't matter, it's reverse, but it doesn't matter. Okay, I want to make a slot pocket here. The center to center of the circle is 5 millimeter. The radius or the dimension is 3. The radius is 1.5. It's the middle of the distance. Select the slot here. Okay, it should be 5 and the radius 1.5. Okay, okay, diameter is 3. Convert this length and make relation as center of the slots and midpoint of the this line. Let's check it, it's remained 1. Okay. Make a dimension about the center of our axis. Let's cut, go to the sketch, the depth of the cut. Is here. Again, from this point and this point, it should be aligned. Okay, it's about the 1 millimeter. It should be 1 millimeter. Change the direction to 1 millimeter. Okay, hide the work point, invisible, select the fillets, make dimensions 0.5 millimeters. Okay, select circle pattern and pattern extrude and the axis about the 6. Okay, again make chamfer or select the chamfer again. This edge remain. Okay, let's go to the drawing to check it. Okay, it's finished. Our part is finished. Let's go to the part 8. Okay, let's drawing. We have a circle here. The diameter is 12 millimeters. Make the dimension to origin vertical and about it's 16 from the origin. Okay, make a parallel. Make a coincident to origin. Again, tangents. Okay, let's trim the extra line. Exit. The thickness is 5 millimeters, but in symmetric. Okay, here we have a thickness here, it's 0.5. The material is a plastic or rubber or PVC, it doesn't matter. Okay, we have a 0.5. We should use the shell order. If you can find from this here, for example shell is here, but you can't find it, you can write it here. Shell, it's up here. Okay, it's totally a preview of the shell. Change it to 0.5. Okay, our part is done. Then let's go to the next part. Part 9. It's pulley. I want to use the revolving instead of the extrude pass order. Okay, go to the sketch. Sketch about like the drawing. I can use extend to reach the point. Make a center line. Okay, you can use it the end of the center line and make it dimension it. The inner hole is 8 diameter. Here we have a 20, after that 18. Twenty, 18, Here we have a 17 and 18. It's 17. Again, it's 18. Let's delete it and reach this here. Okay, about the heights, we have a 1, 4, 52 and it's sorry 5.2 and 6. 1, 4, 1, 4, 5.2. Again, it's 6. Okay, let's delete it because it's not. We have a 2 line. Sorry, use extend. Control Z. Use extend. It's 1 line. Check it again. 8, 2018. Okay. Make a dimension. Okay, it's full constraint. Exits from the sketch and revolving. Here. Let's check the drawing. Okay. Our part is finished. You can change the material to ST37 if it's exit. Okay. You can use the stained steel. It's the refer to 304. Okay, our part is ready. Let's go to the next part. Okay, the part is hinge plate. And we have width here. It's 4 millimeters. It's the width. The length is 14. Go to the sketch from the top. Rectangular. Here width is 4 millimeters. And it's 14. Let me check again. Yes. Okay. And we have a thickness. It's the 1.5 millimeters. Exit. Go to the 3D model. Extrude 1.5 millimeters. Okay. Select the midplane and sketch again. Select the slice graphic. Here we have a circle. Again we have a part. We have an arc here, and it should be mirror. Okay, let me to make relation. Here we have a circle here. The diameter is 6, and here we have a fillet. The radius is 1.5. It's 6 is 1.5. Okay, we have the center of this circle till the bottom is 3 millimeters. It here from the center of the circle on the bottom, it's 3 millimeters. make a tangent, and the circle make a coincidence. Okay, you can mirror this arc about this construction line and select a line to close loop that is for construction. Select on it and deactivate it. Okay. Let me check again. Delete it. Do it again. Deactivate. Okay. Trim the extra line. Extrude. It should be symmetric. About 4 millimeters. Okay. We have a hole here. The diameter of hole is 2.2. It's true. The location is 1.25 and it's the middle of the width. Okay, select a simple hole without seating. The diameter is 2.2 here and here. Okay, it's want to change the direction. Again, edit the sketch. Make a relation from the width here and again. And about the length, it's 1.25. Again, it's the same 1.25. Make a relation. Okay, it's fully constrained. Exits. Here our part is finished. Let me check if there is any fillet. No. Okay, you can change the material to aluminum 6061. Write it 6061. Okay. Our part is done. Let's go to the next part. New part is the lens holder in a camera. Okay, I do it by one option. I use a revolving. Go to this sketch. Here I want to create this sketch. Okay. It's the O-ring setting. Okay, continue till here and close loop. Okay, it's finished. Make a center line and dimension it. In inner diameter we have the 5 diameter. It's 5. Okay. Oh, we can see in a PDF. In top we have a 9. It's 9. Okay. The diameter of the O-ring we have a 10.5. Here for O-ring setting it's 10.5. We can drag it outer. In outer diameter we have 12. It's 12. Again, we have 11. From the bottom diameter order, it's make a collinear, this line and this line, and go to the for the height. It's a 3.5, and for the O-ring, it's 4. And the next is 4 millimeters. Again, we have the total length, it's 8. Okay, let me check to band the freedom, make relation. Okay, it's remained just one dimension. Let me check. Okay, the center line is remain, make dimension it to this point. Okay, it's fully constrained exit. Use a revolve, it's automatically you creates the revolving with the axis and profile. Your activity is 1 in 45 degree. You can change the diameter to 1. In inner we have a thread. If you select it here, the thread is automatically, it's a full length, and it's automatically change the size to 9. It recognizes. Okay, let me check in drawing. It's M9 in the pitch is 1 millimeter. The class of the thread is 6H. Okay, our part is done. The material is aluminum 661, and let's go to the next part. New part, handle lock. It's a simple drawing and simple modeling. Go to the sketch. Choose the display. Okay, we have two circle. One of them is bigger and the bottom is smaller, but it's on a vertical relation. About the origin, okay. The bottom is the radius 3, it means the diameter is 6 and the upper is 14. 6 and 14, and the axis is 20 from this circle, and the bottom circle is 20. Okay, it's 20, and I want coincidence the center of the bottom circle to origin. Okay, it's fully constrained exits. Sorry, I forgot to connect it and close loop. This again, this and make a tangents. Okay, exits. The thickness is 3 millimeters. Extrude this profile, and this profile. It's 3 millimeters. Again, this surface. Create a sketch. Go to the drawing again. We have here diameter 6 and the thickness is 2 millimeter. 5 minus 3, it's 2. And it's concentric with the bottom, with the upper circle. Okay, here When you drag it on it, the center of the circle appear. Make amend 6. Exit. Make it volume 2 millimeters. We have a thread here. The length is 9 millimeter, 40 minus 5, and it's M4. It means your shaft should be 4 millimeters. Okay. Again, sketch on the surface. Here it's 4. Okay, it's moving. Let's concentric with this circle on this. Exit. Make a volume 9 millimeters. Okay, to thread this shaft, select the thread. It automatically do it in a full length. The specification is M4, the glass is 6G, and the designation is M4 in 0.7 pitch. Okay, we have some fillet here. The bottom is a fillet 0.5 and all sharp is 0.5. Go to the fillet, change the amend to millimeter into 0.5 and make edge. This edge, this edge, this edge, here, this edge. Okay. You can change the generic material into rubber, or it can be PVC, depends on your project, but choose the rubber. Okay, our part is finished. Let's go to the next part. Part is a screw. It's a screw with the star handle. I want to modeling with one order in revolving. Here we have a big diameter. I'll show in this view is a 4.5 millimeters. Okay. Sketch about this plane. Select the line. Okay, make a relation. Should be vertical. Here we have 4. Okay, I should define the center line. We have a big diameter is 4.5. Here is 1.5 and bigger is 2. The bigger is should be thread is 2, and here we have a slot. Here is 1.5 millimeter. About the lens, we have the from here is 1.5. This gap we have a 2.5. After that, the length of the thread is 4 millimeters. Okay, exit revolving. It automatically select the axis and the closed loop. Here, select the thread. It's automatically thread the full length, and make a sketch here to should be the star handle. Here we have a shape like this. select the rectangular. Okay, make this length should be a square 1 millimeters. Fold the lens, drag it to up, make this line, and from the origin it's 1.8. Make a relation the vertical from the midpoints of the line and the origin. Okay, exit. Go to the extrude cut. Okay, make a pattern. Circular pattern. Select the feature about the rotational axis. It needs to be flat. The fillet is 0.2. Okay, let me drag it up. Just make a fillet here, here. And drag it. Select the fillets as a circular pattern. Okay. Let me check. Drawing. Okay. Our modeling is done. It's simple. Let's go to the next part. Part 14. It's a fixture for the camera rod in telescope. It's an important feature because I want to use a lot of feature in Inventor. Totally we have a lens. It's a total lens is 53, the height is 15.5, and we have the 19.5 plus the half of the diameter. Here we have the you can consider it as a thickness. Okay, go to the Inventor, select the sketch. I want to use the top plane, rectangular. We have extra rectangular from the two sides. It's 12. You should save the drawing or capture the screenshot from the drawing and look my modeling and drawing in the sketch. Here we have 8. It's for the earring. We can use the relation to ignore repeat the dimensions. Make a relation horizontal from the origin. Okay. Here we have the width. The width is 8, or you can make this length and this length equal, and this length equal. Okay. Here we have the total length is 35. We have here and here rectangular. Select the arc. Also you can delete it. Make the amount again, it's 35. Okay. Delete this and this point. I want to mirror it to avoiding repeats and make it faster sketching. Here is tangent again from this length and this length. Should be tangents. Okay, the tangent arc is 2 millimeters. It should be coincident. Okay, I repeat it again. Make a coincidence. Few millimeters. Okay, the width of the rectangle, if I mention it extra, it should be correct. And here, change it to, okay, it's 2 millimeter, it's 4 millimeters from the length to this line, it's 10 millimeters. Okay, look, it's correct automatically. Trim the extra. Okay, make a length. This line from the origin it's 10 millimeters. Again, make a tangent from this line. Okay. Select the line. It should be for construction. I want to mirror it. Mirror this sketch about the mirror line. Apply. Done. Okay. It's definitely constrained. Exit. The thickness is 5 millimeters. Okay, it's not closed loop. Again, go to this sketch. If it doesn't work, I should. Okay. Thickness is 5.5 millimeters. I want to change it. It's aluminum 661. It's a kind of aluminum alloy. Go to the edge gauge. Here it's 50-55. Again, back to the edge gauge. Here, make a sketch on it. Select the rectangular. The width of rectangular is 2 millimeters. And make a length about 30, or it's also you can change it to 50. Okay, make a dimension it, make a relation. There is a collinear from this length. Also you can drag it here. Finish the sketch. I should to cut this profile sketch about 0.8. Okay. Go to fillet, make amends to 0.5. Sharp should. Okay. Here we have the fillet, because when you machinery it should be fillet. Operator can't do that if it doesn't have a fillet. Okay. Again, you can select the fillets or add a click to add. It's better all fillet in one option, and change it to 0.3 here. line. Okay, it has a fillet. Select OK. Select this plane, make a sketch on it. Slice graphic, rectangular. You can move it. It should be collinear from this surface. Here, change the arc. I want to create the drawing I show you here. Here it's a 14 width about the from the back. It's the lowest surface has a 19.5 from the center of the arc, and the lowest surface and the diameter is 6. Okay, back to sketch. It's 6. It's 14. The center from the bottom is 19.5. Make a equation. Okay, delete it. Make this line at 19.5. Okay, it automatically reach to the center point. It's fully constrained. Exits. Make a volume, but it should be symmetric. Two sides. Okay. The amount of the thickness is 10 millimeters. Here make a fillet point half. This line. Okay. Again, sketch under this surface, slice graphic. Here I want to make a arc here. It should be considered from the distance. Again, it's 10. Okay. The tangent, the important relation is they should be vertical axis, and also project this curve, and it should be to concentric with this. Okay, exit. It should be cut, but it's not close to this gauge again. Make these tangents Okay, finish the sketch again. It should be cut, but it's 0.5, but also it's just this 4 or 5 again. Okay, it doesn't recognize it here. Make a coincidence. Again, exit. Go to the extrude. At this point, create a line. It should accept this profile. Again, let's make our work. Okay, delete the project, trim here. Okay, it's finally recognized. Also go to the here, select the profile, and the circular should be cut. Go to the mirror, mirror this feature about this face. Okay, fillet, change it to have this sharp edge should be fillet. Also, we can fillet this sharp edge. Okay, sketch on this face. Here I want to create it. Okay, back it to sketch, select rectangular. The length is 10. The width is 8 millimeters. Also, it should be collinear. Here about this face. Okay, it's remain just should be midpoint of the line and the midpoint of this face. Exit, extrude cut about the 1 millimeters. Also, it's make it volume. Okay, cut it. The direction is here. Select a fillet 0.5 this sharp edge, and when your machinery inner, it should have the fillets inside this edge and this edge. Okay, you can mirror it, fillet. Okay, when you error it, it describe you have a problem. It's error because it doesn't have a pocket or cutting from this face. Okay, select the mirror, extrusion, and the fillets. Both of them should be make a mirror it. Also, here needs to be fillets. Okay, it's done. I want to create the hole, this hole, and the key cuts here. The diameter is 18 and it's the true hole. Take the hole, it's a simple hole without any seating. When you drag it the mouse on the curve, it's automatically make relation collinear. Change the hole diameter to 8. It's the true termination. Okay. Zero about the direction. Back to the drawing. From when you in a top view, we have a two hole. Here it's just for the socket head screw, and the feature is 3.5. It's for the M3. This hole is suitable for the M3. Select the hole, perpendicular from the top view. Okay. We have the seat is the spots face, and change it to ISO to, okay, it's 2007. It's for the M3. Also, you can change it to 3 points. Okay, sorry about the drawing. I want to change the head 6.5, and here the whole size is 3.4, and the sitting height is 2 mm. Sorry, I forgot to make a location it in drawing. It has from the this line or this face, it's 8 mm. About the width, it's middle of the width, it's 8 mm. Here also you can refer to this dimension. It's when this length is changed, automatically this length also together will change. Make a midpoint, and here, okay, it's fully constrained. I want to create this keyhole. It's the 2 mm. From the this line to center is 5. Sketch. The length is 2 mm. Also from the here, let me check again. It's 5 mm. It should be vertical about the center. Okay, cut it through. Okay, our keyhole is created. Okay, it's also is finished, but remained this face hole. Zoom out. Here we have the hole. It's a 4 diameter, and it should be through all. It's 86. It means it's through all. About this face has a 3 mm, and the thickness is the middle of the thickness. Okay. Take the hole. This face. It's a simple hole. The diameter is 4. Go to the sketch. Perpendicular the view from this face. It's 3 mm, and it should be also horizontal or middle of the thickness. It's fully constrained. Okay. Here we have a short edge. You can make amends. 0.5 mm. Okay. Our sketch and our modeling are finished. Let's go to the next part. It's case, main case camera for the lens. It's complex drawing. If you can capture or screenshot from the drawing and save it, because I don't want to see this drawing. It's I use just baseline, dimension it here, and I just use just revolving option. Okay, let's go to the inventor. As I said, you should save the drawing, and step by step I explain the drawing. Okay, use a line. I see from the drawing inside me what you can use your capture of drawing. Okay, it doesn't matter if it's the line it's not horizontal, it just should be near the drawing shape. Okay, use a line, but it should be center line. Okay, let's dimension it. Maybe it's better to start it from the top because it's the outer dimensioning and we don't have any complaint from the sketch. It's 46. Sorry, it's not the 46, the bottom is 46. Okay. 48. It's 1 millimeters. 43. Again, it's 1 millimeters. This length should be 38.5. Okay, let's drag it here and make relation of origin. Here, make it horizontal relation. It should be vertical. And let me check again. Okay. This line, the second line, it should be 25. Here it's here it should be 46. I think it has the relation. Okay, it's 46. It's okay. Here it's 36.5. Okay, let's change it to ordinary line. Here also it should be 3. Make coincident end up to this point. Okay, we can drag it here. It's 1 millimeters. This line and this line is 39. Okay. Here we have 53. Okay. There is 33.5. Again, we have, let's delete it, extend, it's 1 millimeters. This distance is 68.5. Here we have a 36 diameter trim. It's 31. It's 75. Okay, let's delete it. Repeat it again. Ctrl Z, deactivate the center line option. Make it vertical. This line is 75 again. Here the diameter is 40 millimeters. It should be 20 millimeters. It's 38. And it's 80. Here it's 36. It's 9 millimeters length. It's 24.5. Here we have the it is 1 millimeters. Also, it should be collinear from the this. Okay, sorry, delete the collinear. It should be collinear from the this line. Okay. Drag this line a little. It's 1 millimeters. This diameter is 27. Here is 3 millimeters. Okay, let's to try from the top. It's 50 diameter. Okay, let's drag it to up. From this sentence is 25. Here is 2 millimeters, and it's 1 millimeters. Okay, I should change it to 18.5. It was wrong. Okay. Here, from this line to this line, it's has a 12 offset. It's 2 millimeters. Let's trim it. Okay. Here has a 73. This width is 2 millimeters. Here is 1 millimeters. Okay, drag it up. Okay, let's delete it. I do it again. It's conic. Here to this line. It should be up. Delete again. It's 20 from here. This line is 47. Also, it's 44. Okay. Okay, let's trim it. It doesn't recognize. Okay. This point is 44. Oh, it should be vertical. Okay. It's 42 millimeters, and the diameter 42. It should be 8. It's 2 millimeters. Here also it's 2 millimeters. And this is about this center is 135. Or change its position to this. Okay, let's drag it up. Okay, it's from this center is 7.5. It is 7.5. It's 5 millimeters. Also, it's 39 diameter. One hundred 35. Okay, make a relation and make a coincidence. This point of the line and here. Okay, let's drag it down. It It's 2x one hundred D okay, it's 5. Here we have a theory lens. This diameter is 35 millimeters. Change it again, 34. Okay. Make evaluation from the this midpoint and here. It's 25. It should be colonial from this line. Also has 30 diameters. It's 3. Okay, about the height it's 2. 8. It's 20. And 25. From here it's should be 12. Let me check it. It's 30, okay. It's going up from this line. And it should be like this 12. It should be 12. Distance it's 20. Okay, it's 24 from the top. It should distance from here 3 millimeters. Let me check. It just remains to dimension it to be fully constrained. I think one of them is the center line. Okay, it just remains 1. But also it's finished let me to exit and revolving to see our sketching result. Okay, I think it's not closed loop. Let me check. It should be extra line and should be trimmed. If you want to see the freedom, it is from here. Okay, let me trim it. It has a dimension at first. Maybe it should be coincidence. Okay, delete this here. Dimension, but also maybe I make it the basic dimension. It has a lot of error. It's 20 from here. It's 44. Also it's 20. It just remain 1. Okay, it's moving. It's fully constrained exits. Use revolving. Okay, it's without any problem. Our telescope case are creating. You can section, go to the hub from the XZ plane. You can see the result. Here are the settings for the lens. I want to make a thread, this thread. Here for the thread for the retaining, it's automatically select the best size for your hole. Okay, we have another here. I think it's here. Yes. Here for the setting the lens, we have the thread, and it's finished. Go to the sketch. Here, make a sketch on it, slice, select rectangular. It should be square. Call this line and this line. Make a dimension it 2 millimeters. Here, make a tangent from this line and this line. And also after that, make a vertical relation. Exit, extrude cut, this profile. Okay, close it from section. Here go to the extrude cut. It can recognize it. Let me check it again. Okay, you can drag it or make a amount. It doesn't matter. Go to the fillet. Change it to 0.5. this sharp edge and inside it. Okay, this one, back it here. Okay, make it circular pattern. This extrusion and the fillet from the rotational axis, change it to 20. Okay, it's here. Go to the fillet, select the amount to 1 millimeters. This edge, also this. Change it to 0.5 here and here. Okay, edit it again. This line needed. Also click it to 1 millimeters from the head of the flowscope here. Okay. In the right view, select the YZ plane. Go to the slice graphic. Make a sketch circular. Diameter is 10. From the origin has the distance 24. Okay, make a coincidence from this edge, project it again, center and this line. Exit, go to the extrusion, 28. It should be symmetric. Okay. In the drawing, it's here. It has a 6 diameter hole. Go to the hole. It should be 6. Also, just you can select it to 6. Okay, make a fillet. This line and this line also here. Change it to 1 millimeters. Okay, mirror it. This hole and the fillets. Okay, just selected the fillets. Drag it to down of mirror. This edge and this edge. Okay. It's created. Let's define offsets plane from the XY. It should be negative 25. make a sketch on it, return it to view. Okay, converting it is this circle. It should be parallel, this line and this line, and it should be vertical, this line and this line. Okay. Select the line for construction to midpoint. It should has the 45 degree from the vertical axis. The length is right click and select the line. It should be 16 from the origin and here it's 20. Okay, it should be equal. Exit, make it the volume 25. Or select it to accept. No again. Check packet it. Okay, project it. Control Z, take again. Offset. All of. I want to the length here is 20. Also it should be 10. Exit. Let's edit this feature to symmetric. It should be distance 25. Right. Go to a sketch. Select the feature. Horizontal. Okay, it has a relation from this line. It should be deleted. Extrude cut. Just 5 millimeters. Again. project it, add it, but this should be the new solid. Make it color, some black, hide it, select the two hole, sorry. Let me check. It's 2.5 diameter and 5 is depth. Two point five. It's 5 depths. And should be have an angle of the sketch. Okay, also it's 20, it should be 5. And exit. Go to the fillet. All sharp edge should be around. Make it circle pattern. Just picture. And it doesn't have a lot of feature like a color. It's 10, also it's 20. You can split it if you can't find a split. Also it's here, you can write it in a search command to reach that. This profile and this face. It has a split face. Okay. Okay, it's changed. Let me check it again. If remaining anything, you can change your material to stainless steel, to AISI. is still 37 degrees. Okay, it just remains some inboxes, text like my brand GTCAAD or the brand of telescope is a Spacer Hunter, but here it doesn't matter. Also, we are concentrate on a main feature, it's revolving. Okay, I hope enjoy it. This part is very important. Let's try to do this your own on your project. Let's go to the next part. This part is connecting rod. It has a thread and slot cutting. Uh, let's go to the sketch. Select this plane. Make a relation horizontal this line. Okay, let's go to dimension it. Total length is 36.5. $36.5 millimeters. Here we have the M6, it should be diameter 6. Okay, I should make this line should be for center line. It should be 6. Here we have here it's 8 and 14. It's 8, it's 14. So we have a 5 millimeters diameter. Also is 14 and 6 and 5. It should be 6 millimeters. I have to fit it. Here trim. This diameter should be 5 and here is 6 millimeters. Also it should be collinear. And about the width of the this and width of the grooves cutting is 0.5. Okay, about length we should mention it from this age till the first is 24.5. Here we have the 13.5. Here the first age of flange is 12 lengths. Okay, it's just remaining just groove. It's 6 and 6.5. Also, I just make a dimension just 6. Okay, our sketch is fully. Exit and sketch revolving. Select the OK. The first of our shaft or rod should be thread. It's automatically do it for you. The size is M3. You can change it to isometric profile. Here we have chamfer is 0.5. Also this edge should be here. Here we have the M6. And I think it's finished. Change the material to stainless steel. Stain steel alloy. Can select it. 304. Okay. Our modeling rod is finished. Let's go to the next part. Part 18. It's another shaft with a flange. Go to the sketch. Okay, make it this line should be center line. Here the diameter is 3 and also here is 6 and 3.5. Six, 3.5. Okay, I should change it. It has a relation. Control Z, deactivate center line again. Make coincidence. This diameter should be 3. Okay, about the length. We have a 3, 4, 11. 3. So we can consider it with its 1 millimeter and 11. Also we have a hole here, it's M2. Okay, I do it in 3D tab. Exit, revolving. Here we have M2. Change the standard to ISO. It's M26 or 2 millimeters. This is 4 for the hole depth. Okay. Here we have a range. Cut, it's 2.5. Here the range size is 2.5. Also select a line, but for construction. Here make a vertical, the midpoint of line and origin. Okay. Exit and extrude cut this. It's 3 millimeters. Okay, also you can make a chamfer here, 0.2. Okay, this part is finished. Let's go to the next part. This is a retainer. It makes lens to its location. Select the rectangular, select a line and make it for center line. Here we have the diameter, outer is 45, inner is 48, sorry, outer is 48, inner is 45. 48, and this is for 45. It's 15 about the heights, make a relation here. Okay, exit, revolving, make outside thread, it should be 48 in 5 pitch. Here we have a 2 and 1 millimeter. It's for the range to rotate retainer in a telescope case. It's 2 millimeter. You can dimension it to 60 and make relation midpoint and origin. Also about the mid line. Okay. Extrude cut 1 millimeter. Okay. It needs to be chamfer outer. Or also drag it end of the part to here. Okay. Now select the chamfer. drag it down of feature. Okay, change it to aluminum 6065 661, and you can color it to, for example, green. Okay, our part is finished. Let's go to the next part. Okay, this part is about the sheet metal. The thickness is 0.5 and the material is ST37 or it's galvanized, it doesn't matter, but in drawing you can save a capture of drawing or screenshot it. And let's go to the sketch on the top view. Select the rectangular here, make a dimension the midpoint of the rectangular here. Here it's 6 millimeter the width, and also it's from the total length it's 38 millimeters. It's 12. Here make a fillet about 5.2. Okay, control Z again, trim it, make it construction line, create it, and also this line and this line should be symmetric. Okay, go to the fillets, it should be 5.2. I forgot deactivate. Here make it 5. Okay, it should be 0.55 divided 2. Okay, it's no problem with fillet. Okay, let's make a slot on it. This center here to here it's 15. The diameter is 1.5. And here from the here distance is 2.5. But here I think it should be plus 2.6. Okay, exit, go to the convert sheet metal in the 3D tab, change it to 0.5 millimeters. Okay, select the face, this face, our sketch. Okay, we have an option here, it's hem. In type, should select it rolled. Here change it to reduce element to 1.5, and it should be 250 degrees. It is reverse the direction. Okay. The end of the part, we have a fillet corner here. It's radius 1 millimeters. Sharp edge. Also, we can select it. Okay, our sheet metal part, or change the material to galvanize, steel galvanize. Okay, sheet metal part is done. Let's go to the next part. This part is a leg of telescope that's carrier telescope on itself, and we have three number of it in project. Here we have some hole. I use a baseline from this edge, dimension it to end of height. Go to the sketch YZ plane. Here select the center rectangular. The width is 12 and the height is 150. Close. Go to the extrude 4 millimeters. Select the sketch on this face again. Rectangular. Make a collinear with this edge. The height is 18. Finish. Go to the extrude. Extrude extend to this face. Okay, let's new solid and change the sketch. Here 10. Again, mid point of here. Okay, it again. When you started from the point of the edge, it gets a new relation, and you should find it or delete it. It's 18, and midpoint here and here. Okay. Go to the hole. We have a hole here. It's 4.5. It's a simple hole. It's not ring. Here we have the inner diameter of the diameter, and we have a circular pattern cutting. Go to the sketch here. Describe the center line. Select rectangular. Deactivate the center line, make a relation 25 and 18. The width is 5. Also here, it will constrain exit revolving. Inner we have solid thread. Outside sketch on this face. Project. Again, create rectangular. Diameter is 24. Here create some line, it should be parallel. Okay, the width between the line should be 2 millimeters. Also, it should be symmetric. Create a line for construction. Symmetric, this line and this line, or this line. Okay. Trim the extra line here. Exits. Extrude cut. Okay. Drag it to cut all. Make a fillet 0.5. Also, you can change it to 0.2. Okay. Create a circular pattern. These features. Here is the rotational. And about instant, it's 10 copy of these features. Okay. You can chamfer this sharp edge. Okay, our retaining knots is finished. Let's go to the next part. Part hand wheel. We have a rotation order to start it. Here we have a 5 diameter and the big diameter is 14. Sorry, it's 20 here. We have a length 14 and 6 is for the 20 diameter. Create a sketch. Convert this line to center line. This line should be the diameter 20. Here it's 5. we have a length is 6 millimeters, and here is 14. Exit, revolving axis. Okay, select this surface, create a circular, it's 17. Also project the outer circle, exit, go to the extrude cut, here extrude cuts about 1 millimeters. Again sketch, sorry, sketch on this face, rectangular, the width is 3, slice graphic, from the top to origin it's 12, make a relation vertical, the midpoint of the line and the origin, and you can create a circle, it's 18. Okay, drag it this line and trimming the extra line. Exit, extrude cuts all. Okay, make a fillet 0.5, sharp edge and inner edge. Circular pattern. This extrusion and the fillet should be circular, it's axis rotation, and we need 10 copy of this feature. Okay, let's go to the fillets again, this edge and this edge. Here, sketch on this face, select a circle, on the center it's 15, also project, exit, select extrude cut, and about the 5 millimeters. Okay, again sketch on this face and create 17 diameter circle. Again, make a project this line, exit and extrude cut about 3 millimeters. Okay. Select the hole on this face, perpendicular view, it should be, hole is simple and sitting is countersink, it should be 4, and the diameter of the hole is 2 millimeters. Go to this gauge, select the circle, but it should be for construction. The diameter of the circle is 10. Again, select the circle and it should be for construction. Coincident the center of the hole and the circle and make a relation vertical to origin. Exit. Okay. Again, make a circular hole. It should be 5 instance. Okay, and let me see the drawing if there is any fillet or chamfer. Okay, our modeling at the hand wheel is finished, and you can color it if any feature you want. For example, this feature, you can color it. And let's go to the next part. Okay, I started to assemble all parts. Here, the first assembly, we have a worm gear here, and it's the wire handle to rotate the worm gear. Here I didn't model this worm gear because I did it in my video. I explained to how to modeling the worm gear in Inventor, and I ignore it to model it or insert it here, but in a 3D in a design tab. Here we have a worm gear. It's a lot of gear. We have a bevel gear, worm gear, and spore gear. Okay, let's Control N, create new assembly. Go to the standard assembly. Okay, here in assembly option, place it and insert the part in assembly, the sub assembly. Here you have a worm gear. When you right click, you can rotate about each axis. Here I want to rotate about the Y again. Okay, change the view to shaded. Here your part in assembly is moving around, and when you drag it, it's free. To bend this free, you can right click for the temporary you can ground it, but better you should make a concentrate each plane of the worm gear and the main assembly planes. But here I ground it again, place it, insert the wire, change again about the y-axis. Sorry about my voice, I have a cold. Change this circular face, make a relation axis to axis, drag the wire a little down and make a concentrate the bottom face to here in the worm inner hole. Right. When you rotate this handle, the worm gear is rotate about its axis. But here I grounded, it can rotate. I show you in the main assembly. Okay, let's go to the next sub assembly. Okay, this sub assembly is the side camera that install on a main case assembly. Here it's a main case assembly. It's installed from the side of the main case. Okay, let's insert Okay. Rotate about the Y axis. Okay, right click and ground it. Change the view to shaded. Go to the assembly again, place the holder or rotated ring. Make a constraint axis to axis. Okay, and make relation 4 millimeter from the first of this face and this face should be 4 millimeters. Okay, it should be negative. It's a simple mechanism. We have a groove cut here. We can use a keyhole from here to avoiding a back of ring, and in forward band we have another case here. Sorry, it's like here. Make the constraint axis. On the inner diameter inside we have a thread. It's avoiding from this straight, and from the back we have a key here. It doesn't allow to going down. It's just rotating on its location. We have a lens here. It should be installed. One of them is the front and another is the bottom. Eye contact. Okay. Go to the view. You should make a half section about the XY. Okay. Make a relation to sitting here. You can use the inserts from here to this sitting. Okay. It's a stick and it's not free. Exit from the half view. Okay, this part is finished. It was the easy sub-assembly. Let's go to the main case camera. Okay, here we have a main case lens. It's sub-assembly. Also, in itself, it has a lot of other sub-assembly here, you see. And I want to gathering all part and assembly here. Okay, I want first start it from the side camera and the housing. In assembly, create a new assembly here. Insert the case and rotate about the Z axis. Again, Y. It should be rotate again. but it doesn't matter. I want to make a relation about the case planes and the main assembly planes. Here YZ and XY. This plane and this plane. Okay, it should be reverse. Look, this handle rotating, going to down. Okay, look, it's fixed. It doesn't need to right click and make it ground because it's temporary and it's not the right way. Place the cover side camera, rotate about x-axis, make this hole here and this hole here. You should be coincident again, this hole and this hole. Okay, the face should be sitting on the surface. Okay, again insert this sub-assembly side camera. Create a new constraint. Body should be reversed. Select the lines. Okay. Again, make this face and this face should be four millimeters. But it should be negative. Okay, it should be ground because it's fixed. It doesn't need to rotate. Okay, here we have a hand, star rotating our hand wheel. Also, we need another make a constraint again from the piece. Also, it should select the surface, and here should be 4 millimeters. Also about this view, make it reverse line. Grab this face, and this face should be 4 millimeters. Okay. Here we have the end lens, and also we have eye sights. Place the end lens, make a relation between the case of 3 millimeters. drag it to its location. This face and here. Okay, delete this page. Repeat again. XY plane and YX, but it should be reversed. Again, this plane and this plane, but it is 3 millimeters. Okay. Place the eyesights, rotate about y-axis. Make a relation. Okay. This way and this way. We have a bolt here to stick this case to the legs. Also, I make a pattern, but here I want to make it one by one. Okay, insert the two clamp, make a relation, this radius and the case frame cylindrical. Between each clamps we have an offset 40 millimeters. Also this face of clamp and here has a 10 millimeters offset. Apply. Again, place the under of the clamp, but it should rotate about Z. 1 and 2. Okay, make it this face and this face. Flush. This face and this face again. Flush. The off face and this off face should be flush. Okay. Okay, it's moving here. Let's make this face and the origin plane here should be 0. Okay. We have some screw here. It's the standard. The standard is 316. It's M4 in 6mm length. Under the place, we have a place from the continent. Okay, type it 316. Okay, it's the rooster screw M4 in 6 lengths. Rotate about the Z. It doesn't matter, I make it the relation 1 and 2. Okay, this rooster screw. We call it the rooster because it's shaped like a rooster. Maybe it's not. Let me check. Here we have my modeling screw build. Let's insert. It's here. 1, 2, 3, and 4. Okay, make a relation. It should be tangents. Okay, let's make all the screw in position. After that, I want to make all sitting. Okay, remain one. It's far from our assembly. Let's do relation and close it. Number 2, it's here. Okay. Make it tangent, but select this face and this face. Okay. For all of them. Okay. Let's rotate again. Let me make an angle about 6z. Okay, let me check. Okay. It doesn't rotate about its axis. Okay, I think all we just needed to add is lens position. Yes, make half section to see the all lens. Okay, here we have a rod here to make a space from the lens because lens sitting under this rod. The lens doesn't sit on the case. It's because of the ban of the machinery in inner with the lace machine. Okay, here first we have a golden retainer. Here we section again to see the inner. Okay, the first one is a golden retainer. It's a bigger retainer. Rotates about Y. But also it should be reverse. Okay, you can use a insert. Let's drag to up. Make it this face. Go to the insert. Make it this face. Here, this setting. Next is the purple. I think the color is purple. Also rotation. Make insert space and here this space. Okay, another is the blue one. Let me check again. Oh, you knocked it. Okay, that's cool. Rotate about Y again. Make insert this face and here this location. Okay. Another is orange. Insert the orange retainer. Rotate about Y. Okay, let's insert this face and this setting. Okay. Again, okay, rotate about X. This setting and here. Here we have a rod. But it's sitting here. The lens big. Should first insert the lens big. It's here. Rotate about Y. Again. Okay. Here go to the inserts. Let me check again. What should be sitting? If you look, all lenses are sitting on its location, just remain the rod. Here the rod's made of aluminium 6061. Insert this face and should be sitting here. Okay, it should be reversed. Okay, let me check if there is anything here that it's remain. Okay. Let's exit from half sketch. Okay, our main case assembly is finished. It's the big assembly, but it's a part of the main assembly. Also, it's sub-assembly. But we finish all. Let's go to the main assembly and gathering all parts in project. Okay, on this part I want to assemble these legs and the top of cover here. Okay, go to the new assembly, place in parts. Here we have a hinge leg, change view to shaded. Again, place the cover, hinge cover. Okay, this hole and this hole should be concentric. This face will stick to this face. Okay, it's turning around its axis. Let me this face and this face should be zero angular relation. We can right click and make it ground. Here we have 2 for 6 legs, and each 2 legs have a 1 leg. It's a freedom to moving up and down and make a telescope height with this star handle. It has a simple mechanism. And okay, let's go to insert this assembly to make. Okay, here I want to insert the main part. We have this part, the name you can find in below. It's a gear down, but I name it connector legs. Let's insert it. Connector legs. It's here. Okay, change the view, shade it, right click, ground it. Okay, but also it doesn't matter. The handle should be here or the other side. Okay, let's insert the legs. I think it's better to insert legs. Here in the case you have the assembled legs 1, 2, 3, 4, 5 and 6. Each double leg should be make concentric. One of them should be here, and also it should be this face, stick to this face, and make a coincident concentric. Okay, let me check. Okay, when I rotate the other should be rotate together and make a relation here to flash. Okay, when I rotate together should be rotate. Again, another part, and I mean the another leg should be have a relation as I did. Okay. Let me insert the middle legs. It's for the adjusting the telescope heights here, and legs 1, 2, and 3. I make a sketch or mark a circle. The circle should be have a concentric with this hole, but you can also counting to 15th hole and make a relation. This hole, also this hole. Okay, put it in. This face is smooth. Okay, make a stick. Okay, remain one. Okay, let's insert this cover, store handle, and simple mechanism. Here is a holder box 1, 2, and 3. Make this hole and this. Okay, this face and this face should be 0. Also this face and this face. Okay, wait for the next. this face and this face. Okay, remain one. Like it's far from their legs. Change the reverse. Make it this face and this face should be the angular 0. And what was it? Let me check. Okay, it's here. Space and this space. Okay, it's done. Let's insert the stall. Let me hide it. We have this shaft and the spring here. When you pull down, these legs will free and going up and down, and these legs have engagement with this here in holding box here. The left legs going stick to this male boss, extrude boss. This door handle and have a distance. Holder box is 1.5. Star handle 1, 2, and 3. Here and here make it 1.5 millimeters. And this hole should be concentric with this hole. Okay, again for this star remains 1.0 and this hole and this hole. One point half offset. Again this hole and this hole. Okay, let's insert this shaft. Is the shaft holder. Insert. It's a shaft holder. 1, 2, 3. Okay, let me check. This side should be here. Reverse. Okay. This face and this face should be flush. Again. Reverse. Okay. Here we have a screw. The screw standard is ISO 7046 M2 in 6/8. Insert. Okay, that's under the place here. The standard is 7046. It's a countersink ISO. Here when you hold your mouse on it, it's choose the suitable screw for your hole. You can sit in here. Also, I should make it this old shaft here 2 millimeters. It should be positive. Also 1 millimeters. Okay, it's better. The shaft holder 3 again 1 millimeters. 1 millimeters. Okay, insert again this screw. You can change the size. For example, when you click the change the size, the table of the screw will appear. Here M2 in 3. Or also I can change it to 4 and replace all screw like this should be changed to M2 in 4 millimeter length. Okay. Here we have let me look. Okay, we have a handle here. The handle is handle lock. Let's insert it. Handle lock. Okay. This screw of the handle should be here. Also this face and this face should be have a coincidence. In the inner I want to make a section view. Doesn't matter which plan you choose, but it should not be in the top. Okay. Click on it, normal to view. Here we have a gear. If we have a roller bearing is not a ball. The standard is here. It's DIN 7720. Okay. The ball bearing here also. We have this gear. It's gear ratio 1. But I want to also let me hide it. And okay. This is the roller bearing. I want to insert it, but the dimension and properties of this ball. Okay. is 720. Okay, let's insert. Okay, it's 720. And when you right click on it, it's make your old image. Okay, the important part of ball bearing is the inner circle for your shaft. It's a 30 diameter. Let me check. It's 30. Here is 30, 47, 12. 30, 30, 47, 12. Okay. That's the main ball bearing. Another is this part. It's the gear ratio 1. Let me find it in assembly. Okay, yeah. Let me measure it. And also this face should be sitting here. Okay, it rotates. The inner ball bearing rotate, the other is a stick to this holding. And when you want to exit out or exit the ball bearing, you can pull it up. Here, this face of the ball bearing is moving or exit from your holding. Okay, another part is this part. It's a triangle. Let me exit from. Let's exit the section view. Our U shape should be this. For example, this form here should be the left of telescope. When you see it from the top, it's left of telescope. Let's insert it, triangle. Make it circle here. Should be reverse. Okay. And this face should sitting on this face. Okay, let me check. In this view, it should be angular bounce. This face should be. Here's some feature. The basic is here. It's to rotate about the. Let me see the x-axis. The case of telescope rotate about the x-axis. This name is fixture stand. Fixture it stands. Okay, let me fix it. Make it this rectangle or here. Okay. We can insert the case here. Assembly of the main case. Rotate about Y. Also about X. This hole and this hole. Also this hole and this hole should be concentric. Again, this face should be sitting under this fixture. Okay, it has a screw. The screw is a socket 4762. We can drag it up, automatically create another picture. Okay, our telescope are going to be done. Here we have a worm gear. Let's insert. Make this face and this face should be sitting right. This model of the worm gear and this gear should be same, equal. Here we have a washer, it's a spring washer. The standard is 127 and another. We have a nut here, it's 439. Okay, let's insert. The washer is 127. And the nut is 439. Okay. We have a worm gear here again, we do it the same. We can right click, Ctrl C, copy of it and import it. Doesn't need to place it. Reverse. Make it this face. For the nuts, right. Remain the big gear here. Also, we have a We can make a skate, make a section. Here we have this pulley, this is shaft key. Let's place it, shaft key. Make a relation here. Okay. Another, we have pulley, the smallest diameter should stick to shaft key. Okay. Make it reverse. Here we have a spring and the nuts. Spring is 127 and the knot is 439. Okay. In this side again, repeat again. Okay, also remain the year. It's a screw gear. In assembly is here. This face and this face. Okay. And let me check again. I think our assembly is done. Let me check. Is it from section? And let me show all parts. All visible. Okay, here we have a screw. I forgot to insert it. The standard is 315. And we have a knot here. Okay, 315. What else I forgot to insert it is 835. 835. We have a screw, but the both of side is screw. Okay, let me right click, change the size, M4 in 20. I think 1, 2, 3. Let me check. 25. I'll change to 25 and replace or apply. Make insert content for here, also here. It should be -6. Do it for all. Okay, let's insert the screw 315. Let's insert the knot for 39. Okay, the last component create our telescope project is finished. I hope you enjoy it, especially the astronauts guys who loves the star and loves the Inventor and SolidWorks guys. I hope like it. Share this video, this project to your friends, and please, if you enjoy it, subscribe my channel and save my video, and you can do it your own in your laptop, in your PC. It's working in reality. Okay, thank you very much, and thanks for watching my videos. Goodbye.